My next guest is Siddharth. He's the founder of Pivot Robots. Previously, he's been with Carnegie Mellon University and Meta Labs, just like our previous guest. And today I want to understand from him why he's picked this problem statement, his thoughts on foundation vision model, monetization in manufacturing, and so on. So let's welcome our next guest. Hi, Siddharth. Welcome to.
Hi, Kalyani. Nice to meet you. Thanks for having me.
Yesterday, I was talking to another Carnegie Mellon University graduate a long time ago, but about world models.
hmm
And I always start my question around what is intelligence according to people who've studied and done work in modeling, right? In intelligence, AI stuff. I was asking him what is intelligence according to you. And so I would start the same question for you, like what according to you is intelligence?
When I think of intelligence, I think of pretty much, I'd say, the textbook definition, which is that given some problem statement or some data, you have some task you're measuring performance against. And as I provide that model or whatever process that I'm using with more and more data, my task performance increases. Generally speaking, that's what when I think of machine learning, that's what I think of. When I think of intelligence, I think like, okay, as I get more and more data points, does my pattern recognition get better? So I can actually start improving on that task quickly. I think what we've seen recently is that you need less and less data to actually start getting more and more performance out of your systems. Like before, if I had to do some task, I would start training everything. I would start every single machine learning model training from scratch. But now I need less and less data to get better and better performance. Like with GPT, I can give it 5 examples of, hey, this is a new task. This is how you do it, and ask it on the next question, hey, solve this new task. It can already pick up that pattern recognition pretty fast. So I think it's more intelligent than the previous series of models.
But is the amount of training data or even the lack of, but is learning modules required to develop intelligence? Like I'm not
Ju-
talking just, I'm taking from the analogy of biological beings and like ants and like so many people in our environment learn very differently. So I'm just trying to understand, did
I
you,
feel, mhm.
go ahead.
Yeah, I feel like there's usually two parts of, if I really think of like biological intelligence that exists. Like one part is like there's like our memory, which is where we can recall facts and like make connections to different things. So like you tell me a certain word and I can already in my head picture 10 related words to that. And the second thing that I think is really important is pattern recognition. Given that I've seen like in mathematics almost, if I've seen like, oh, if I apply like addition over here and I change the numbers, it doesn't matter. The algorithm that I apply is the same, the pattern that applies is the same, or like if I'm learning about like, hey, these are the kind of things I should eat when you go to the jungle, and then you show me something that's like clearly not like a fruit or vegetable, my body automatically pattern recognizes like, oh, that might kill me, so maybe I should avoid it. So I think those are two like core components of intelligence that I usually view. Then you mentioned the part learning over there. I think learning is generally speaking how these individual components improve over time. Like as my experiences come, how much better does my pattern recognition get? Or as my experiences come, how much better can I recall facts that I can use later on, so my memory improves.
Got it. And so and I was also, I think when you said pattern recognition, I also think you meant vision as a part of it because you need vision to pattern recognize, at least in biological being. We see things, perceive it, and then pattern match it, right? So I'm already kind of thinking on that lines. But then knowing what you know and the robotics, where I was watching this interview from Ilya, who's now who was in the founding team of OpenAI, and he said he earlier took on robotics, but because of the training data problem, he kind of gave up, and he was tinkering around, and OpenAI just happened to happen. What is the part about robotics that a lot of people end up kind of giving up after a certain point of time? I've seen this as a pattern in a lot of places. Like I don't want to recall specific use
Yeah.
cases, but beyond the point. So what is it, and like what got you to still go for it?
Yep. So I think there's like the first aspect of it is like let's see like why GPT was hugely successful. So like I would say that's the one like very mainstream application that people canonically think like, oh, once ChatGPT came out, suddenly like AI was a thing. Before that, it was something that was just kind of existed. These algorithms existed, but they were not a big thing yet, right? So then with ChatGPT, what they really did was is they realized like, hey, we have this like general purpose like learning algorithm, the transformer, that model that's actually quite good at learning patterns and quite good at like predicting next words. And then they really started feeding the machine. So you go back to GPT-1 and it was not a very big model. GPT-2 was not a very big model. GPT-3 suddenly is like 175 billion parameters. And suddenly like everybody starts scaling the number of parameters and they find out like, hey, I'm actually not just training on like, when I train too many parameters, you train with a lot of data. And as I increase the number of data, I start seeing that like my model performance increases every time. It doesn't stop. It doesn't ever plateau. It's actually keeps increasing. And to feed that machine, you need lots of readily available, easy to consume data. The internet is the perfect source of that. So like the chat GPT was trained on almost the whole internet. Like you get that. A lot of people love to say the term internet scale training, like they train on that much data. And then you got this kind of amazing generalization and properties. Now, if you look at the inputs and outputs of a text-based model, like a large language model, the input is text, the output is text. The internet is stored mostly in terms of text. There's images and videos, but a lot of material exists that's purely in text. So training my algorithm for ChatGPT, is not that difficult, compared to robotics. Now, if you look at one step above robotics, there's video models. Thankfully for video model, which is, about like given a single photo, predict how the physics evolves, or given an image completed or make changes to it, there's lots of images you can start using. So we start seeing like very good results on image generation or video generation now. Like Sora came out, Nano Banana came out from Google, right? Now, when you as a human are taking actions in the world, you're not just perceiving, you're also acting. And you have way more senses than just beyond sight, right? You feel like tactile touch is a very important thing. You also hear, like imagine like I'm trying to like pick a fruit out of the tree. Like I often look at like how the leaves rustle, or like when I push two things, like I hear how I make contact with something to understand how hard or soft it is. So there's all these senses sort of come together. That sort of data set doesn't exist, right? Like it really doesn't exist. So that's why the data problem, I think, is fundamentally what's limited robotics. And there's no safe way of collecting it either. Like, okay, it's fine if I like have a chat GPT model put into some use where it's 80% accurate and the user knows it's 80% accurate. That's fine. If my robot is 80% safe, like in the real world, only 80% of the time, like let's see a dishwashing robot. 80% of the time it works, but 20% of the time it drops your dish. Probably like by the time it's finished cleaning your dishes in a week, you've lost more dishes than the cost of the robot itself, right? So even deploying these kind of robots to start collecting that data becomes very expensive very quickly. So I think a lot of people have said that generally speaking, it's the data that's the issue. And then most modern approaches now are like trying to like find a way to like use, hey, like if I have this model that's really good at text and I have this model that's really good at like video, can I like use both of these to bootstrap my model training for robotics so that I actually need less data when actually solving that robotics problem? Does that make sense?
Yeah, yeah, fair.
Yeah.
Data problem. Yeah, I got it. Like that's what I was trying to understand. Whether it's just data problem, because then I want to ask you, how are you solving that?
I think data problem is definitely what makes it difficult from the get go, especially when you're like trying to train these large, like what's termed as VLAs, right? Like vision language action models. Those are the models that are generally speaking not just like take in text or just vision, like they also tell you what actions to perform for the robot. How
But
you
more so,
sort
your
of,
point is there's lack of structured data. Right? You're saying
yeah.
like in what pattern, what you're I'm sensing. You're saying there was structured text data across the internet. We don't have that structure in robotics. Like
I
every
don't think it's a structure that's purely the issue. I think it's purely the quantity of data. There's just not like how many people out there, like how do you even collect tactile data, right? You have to suddenly start wearing these specialized gloves that tell you like, oh, when I was holding this apple, I was applying this much force. So my robot knows, oh, when you hold like, imagine like the best example, like holding an egg, okay? Like you're teaching a robot how to hold objects. You teach it how to hold an apple. You teach it how to hold a carrot. Okay, great. You can hold those two things. Next thing, you give it an egg. It holds it so strongly that the egg pops immediately, right? Because it doesn't know that, okay, I don't have to put the maximum amount of force. I have to put less amount of force on that. So to collect that kind of specific data just doesn't exist. Like how many people out there are holding force, like measuring gloves and lining that up with like video so I can actually get that annotated data. It just doesn't like exist. Startups now have come out trying to collect that. But generally speaking, that's not been the case.
got it. And this is why you're saying even a 99% in robotics may still be easier, let's say self-driving car, but even 1% unsolved problem is still something you can't take to production stage then, right? Because
Generally
it's
speaking, that's the case, I would say. Because like safety is a big concern, and also like the cost of like doing something wrong is really high in the physical world. Let's look at like what's been probably the most successful AI app is like AI coding, right? That's worked really well. Now the good thing about that is it's all human verified. Like Cursor has done really well. If I go on Cursor and ask it to generate a website for me, and I don't know, it hallucinated the name of something, that's not really the end of the world, right? I can go and change it. I know how to interact with the code editor and figure that out. I can solve that problem. And before it even like makes any impact in real life, it's already been patched. Very easy to patch. If you have a robot doing a task in, let's say, manufacturing. So I work in the manufacturing space, right? And if I'm using a pure AI based approach, like LLM based approach, and then my robot accidentally breaks apart, it's completely possible that the part it broke's value costs more than the entire robot itself. At that point, even a 1% failure rate still makes putting like my robot into production have negative ROI. But Cursor, generally speaking, has positive ROI because it does 80% of the work for me. And even if it's wrong 20% of the time, I can always correct it at no cost.
But
So
then
that's what makes, sorry?
why do you pick manufacturing then? Such a hard problem. And then robotics, which is another hard problem. You've combined the two hard problems.
I think the best answer to do that is like really fate. Once you like end up like working on systems that interact with the real world, it's really addicting and it's a lot of fun. And once you see like, oh, I'm actually working with physical algorithms, like physical AI and like things that actually impact the real world, it's really hard to go back and think like, okay, working on pure software is going to make me happy in life. Um, I found that like just like the joy of seeing things move, the joy of seeing things be made is just really, really interesting. That's really like the reason why I'm passionate about it, but that's also a practical reason. Like if I really think really hard about it, and I think that like, okay, AI is going to get really good. Anthropic's going to make some insane like cloud code 3.0 or 4.0, like, when they release Opus 5.0 or 6.0, is going to completely solve coding. That effect is that the value of software engineering is going to go down, right? And ultimately, we should trend towards zero. Like software, as people say, will become so abundant and free because software is so easy to replicate and scale. And I can like just run like an infinite number of agents in parallel and it'll generate this amazing web app for me. That if software gets solved, then what really remains? Like the margins there will go to zero. Only thing that'll dominate is like the cost of running the model, right? And then all these SaaS apps in theory should have no margins, right? Like over the long run, because any piece of software I see, like Salesforce, HubSpot, etc., I can all just replicate instantly. Then what really remains is like physical goods and physical things will really be the only thing that retain value. So from a practical perspective, if I actually believe that AI is going to accelerate at the speed it does, then pivoting to the next frontier, which is robotics, makes a lot more sense. I might have missed the LLM wave, but I don't want to miss the robotics wave, right?
Yeah, fair. And that would be the next stage anyway, right? Like since I started studying human AI interaction, I did notice that there are so many limitations with LLMs right now. Current the feedback loop is missing. I have to come and input everything based. So let's say it gave me a 6 structure plan, then I have to go and give it that feedback on what happened to that plan. Why can't you just see and be with me here and just see that it happened, right? So this constant feeding of information through docs and context and all gets at some point tiring and you
Yeah.
will stop wanting to do that for everything. So I also see that limitation. That is what got me to understand and study world models and talk to him about where we are and hence like
Hmm.
I get where you're coming from. That is looking like the next frontier in intelligence, like spatial intelligence. So why did you pick US then? Like manufacturing, I get it, okay, valid, but US is not a country that is usually associated with manufacturing. Like it's always the
Hmm.
East. So what got you to take that decision?
So it's a very like if you think where automation will come first, where robots are not cheap, robots are expensive, it will really come in the space where the need is the highest, right? Let's look at the example of India. India, there's still a large young population that will still take manufacturing jobs and you'll be able to fill your factories with workers and you wouldn't be looking that hard for them. And more often than not, and I've looked at this extensively, like finding a good argument to put robotics in a place where you don't have extremely high production, like where you don't like, I'm not producing like a million parts and robots are the best way to scale it, generally speaking, is a negative ROI decision. But in the US, given the higher cost of wages and the difficulty in finding labor over here, more often than not, if I can find a way to automate, I am saving money as a manufacturer. So the business case in India doesn't exist yet. And maybe that's for the betterment of India. It's like, okay, right now, we really need people to pick up these skills and get these jobs, right? But I feel like the US probably has no choice but to automate manufacturing to a large extent because young people over here are not really passionate about like manufacturing. I don't think in India they're too passionate either. Like, if I really think about it from a blue collar worker, would I rather be in a dark, dusty factory working all day, or would I rather find a job working at like let's say Walmart, right, or like work at a coffee shop? Those jobs are generally more preferable, And even though you might be like, oh, that's still not the best job for career betterment, sure, but like I'd still rather be in an AC environment than be in a non-AC environment, like literally breathing in toxic fumes.
Fair enough. One philosophical question, and then we'll move to pivot robots. So
Hmm.
then, if the software is going to be taken, and then there's hardware also where AI and robotics is coming, like what kind of impact does that have philosophically on labor market? Like in US, like who will get to keep what jobs then at some point? Have you like thought about this at all?
I do think a lot about this. What I generally speaking think is that more often than not, it's going to be less of like enabling like completely taking away jobs versus people shifting to different roles and the world just producing a lot more. Like I feel like the demand for physical goods is just going to keep rising. We need way more energy, we need way more planes, we need way more cars for people, we need way more houses. So like if I have robots that enable the same construction crew to make like 10 times more houses per year, think about how amazing that is for India if that happened. If I could make 10 times more houses per year, like you'd be able to like help so many people improve their lives. And I don't think those like the demand for 10 houses is going to go away.
But the demand would go away at some point when people stop making the money they're making. It's as a trend, it would be like it would be deflationary, right? It would be anti-inflation.
I think that is true. I think that timescale is not going to be as compressed as at least some people believe it to be, which is like, oh, you're going to take off so fast that within 5 years there are no jobs. I don't think that's going to be the case. I think by the time we reach the point where there's so much abundance because of all software being automated, all hardware being automated, we'll fundamentally have to start thinking about shifting to different economic models. And I think at that point, it won't be scary. I think it'll be like, oh, that's the obvious next step. Like life has been getting easier for the last 5 to 10 years. Maybe it's time that everybody start getting a a universal income from the government, right?
Okay, let's come to Pivot Robots. So, like, how long has it been? And I researched some bit of it. Is it just foundation visual models right now, or are you exploring world models? Like, what the journey's
Yep.
been like?
So we've been at this for about 2 years right now. And I think a lot of what we realized is like we have to be very pragmatic in terms of where we use AI. We're not like there's a lot of tasks in robotics. You might have seen people like, oh, I'm going to do home robotics, or I'm going to do like pick and place, like for warehouse logistics. You know, and a lot of those tasks, it really is okay to have like centimeter level precision and just try to solve as generally as possible. And then over there, you start looking into approaches that can be more general, like world models, etc. But we're really in a space where like we have to get sub millimeter precision because we're doing surface finishing of metals. And that's either grinding, sanding, polishing. And for us, like we can't use AI everywhere because if we do, like we could destroy our customers' parts. And the last thing we want to do is destroy our customers' parts because they're very, very expensive parts. So for us, I think the journey has really been in figuring out like, hey, one day like we're going to like use an AI model to solve all of our problems. But right now it's about finding the right places to use it, putting it around a very strong harness, kind of like how agents are like an LLM surrounded by a very good harness of code that enables it to like do its task better. And for us, that's just like really good robotics algorithms written down, supported by like vision AI to be able to figure out what task to do and using that to solve the problem and collecting the data set that enables us to solve these high precision tasks and collecting this very valuable data that you wouldn't expect like LLMs to be able to solve or like the next like physical intelligence to be able to solve. Like
But you
an example, like ChatGPT right now, they might be really good at like like these general tasks and can solve like a large variety of tasks but in a shallow way. But if you ask ChatGPT to solve, I don't know, some very specific finance tasks that only someone who has 30 years of industry experience can solve, it'll probably struggle, right? We're trying to learn those same skills for our robots right now because we're not trying to solve like pick and place, like, oh, put this into that basket. We're trying to learn a skill that a worker has developed over years and transfer that into a robot. So that requires a little bit of care to collect that data before you can even start learning that.
got it. Two questions. I'll go one
Mhm.
by one on what you just said. One is this just a AI or ML layer on existing robots or machinery as well, or you've created your own hardware with the AI layer from scratch?
So we haven't created our own hardware. We use off-the-shelf robots. And that purely exists because in the industry we are in, the six-axis robot arms are a very good medium to be able to solve problems, and they're able to handle the realities of the manufacturing environment. Like we work in foundries where there's like metal foundries where there's so much dust being produced that like if you put something that's not like a very well certified arm, then it's going to get spoiled within like 6 months. Like one hour, 6 months, like within like a month. Metal dust covering all the joints and it'll stop working. So the hardware for working these environments already exists. So we just use that directly. The hard part with always this has been is like you can think like, okay, the kind of six-axis industrial robot arms are like, when you think of a Tesla factory, you might have seen some videos. You see these big arms, that are doing these tasks, but they always keep doing the same task over and over again, right? You don't really change too much what tasks they do. The robots we are working on allow it to adapt per part and work in a high mix environment. So our software enables the robot that, the same robot that Tesla would use, but be able to work for like, let's say instead of just one or two cars, be able to work for like n number of cars is really our goal at Pivot Robotics.
Like they're more agile, you're saying, to
More
different
agile,
parts.
exactly, yes. Make it easier to like onboard new parts and do new tasks for the robot.
Which means then you don't have to keep designing for every separate manufacturer or client separately. Like you design something and you can keep customizing it, is what I'm understanding.
Yeah, you don't need to keep rewriting the software for it. Like currently you have a expensive robot programmer come in and rewrite the software per part, and suddenly you don't need to do that anymore. So actually there's two forms of generalization. One is like intra part and inter parts. And like imagine like I'm producing like 5,000 parts, right? For each of them I need to write like a new program. That's very expensive to call a robot programmer to come in and write each of those. Now think that I am producing only one of those parts right now, but each part has some slight variation which requires some slight deviation from the process, you know? Like imagine like I'm producing, I don't know, like I'm bolting these doors onto the car, but each time the door is not exactly the right position, I have to keep adjusting it slightly. So both these things require you to generalize and adjust to it.
And data acquisition, how difficult was it? Considering you gave me an example where like there's so much of material in the air, the camera might get, you know, fully covered with the dust particles. How do you get your data sorted? Is it acquired or like creating it?
So it's because our system uses a lot of vision already. Like for every part of the process, instead of using any hard coded system, they use a lot of vision to guide it. We just naturally collect the data we need. And I think like to solve the problem itself, we need the sensing at hand. So we need like force compliance. We will to figure out how much force is being applied by the tool that we're applying on the part. So like when you're doing like let's say sanding of a part, you know how much force you're applying to get the desired finish you want. So since we're collecting all of that naturally, I think we collect the data we need. We don't really worry too much about that part specifically. But the flip side is for us to collect lots of data, we need to put robots out there, right? For me to solve this problem better and better, I need to put lots of robots out there. So like I have to bootstrap that from the scratch. So right now we use lots of heuristics and like lots of classical robotics algorithms to guide it. But we have like an engine in place that as the more and more data comes in, our system becomes more generalized and can perform better on new tasks. And that enables us to like deploy more robots. So like really the term that we like try to like define in ourselves is like a flywheel.
And how much data is actually needed? Like, is your challenge around compute or inference ever going to be a problem with the kind of data you're collecting? There's so many frames and there's so much storage, and I'm just trying to
Don't
understand.
think I don't think inference is going to be a big challenge for us per se. Because like I don't think the models we're going to be running are ever going to be as huge as like ChatGPT is. Yeah.
And
Generally
your
speaking, like for these control algorithms, you actually don't need like such insanely large models. Like if you look at like the kind of model that you might use, like you might have seen like a lot of humanoids, right? The policies for humanoids walking, the models themselves are like really small, like really significantly smaller than you would see for like ChatGPT. I think like it'd be like in the millions of parameters instead of billions of parameters.
Oh, that's so interesting because I was going to ask you the trade cost benefit analysis of inference or AI versus a human labor actually uh, giving that service. In India, I think if this were to ever happen to India, human labor would win. Like it's really cheap to do
Yeah.
manufacturing. The laborers get paid $100 a month sometimes.
You raise a good question. There's actually two interesting challenges over there. One thing is that like imagine you're executing something in the real world, right? I actually cannot afford network delays because like imagine my robot's job is to catch a ball, okay? The ball is coming, it's being thrown in the air, and suddenly for some reason I drop a couple packets while communicating. Inference time, you can forget about that. Like there's some network delay. By the time I've caught back up, the ball has already gone and I failed my task. So more often than not, I need my model to run in like a very tight control loop so I can actually react in time to what's happening. So fundamentally, I need very good tricks or I need somebody to be able to run that inference very fast because like otherwise I'll just miss my task, right? So going bigger and bigger models actually probably is unsustainable to do dynamic tasks.
Yeah, that resources, right? Like electricity, water. Like if it fails even for like 10 minutes, let's say the electricity is down, that would impact your work, right?
Yep,
But like
exactly.
for
And then
you,
like Wi-Fi. Wi-Fi goes down, then my like a lot of factories have like power outages. If that goes down, then suddenly I can no longer run my system, and that's pretty catastrophic for a
yeah,
factory.
yeah, I was writing that down, reference cost.
Yeah.
I was thinking of what are the challenges, what would be some of the challenges. I was trying to kind of just brainstorm with myself, but what are really your challenges then right now?
So with inference, then like at least for inference, we just run inference on-prem. So we just put a computer there which runs the model directly, and then we don't really have that trade-off like of hey, you're running like an extremely large model, and like you compare the costs versus human labor. Not really the challenge. The challenge more is like the cost of the sensing required and the cost of the robot required. We need to wrap that into like a very attractive package for a customer to actually want to adopt robotics, and all this can be quite expensive. There's like a big wave of low cost robotics showing up, but I would say that it's hard for us to fully benefit from that when the environment we work in is so dusty and so like dangerous and difficult. It's not like a robot that needs to work in a lab. It's a robot that needs to be put into a customer site and work for the next 10 years reliably. That's when the robots start to make sense, you know? So given that we can't really benefit from low cost robotics, like being able to have very good ROI for our customers is extremely important.
And what like sets you apart? Like, what is the moat now? Is it the quality of training? Is it the quality of data? What is the moat?
I think the moat that we have is primarily that we're able to like generalize on tasks that like traditionally customers have not been able to generalize on. Like in the past, that oh, you get a robot programmer to come in and do this task to like onboard your robot onto a new thing. But given the fact that like we're not using so much traditional robotics and we've really switched to like more of a modern approach built around AI, we're able to actually get much better generalization. And because of that, we're able to like reduce the time to onboard a new part massively, which really enables customers to be like, hey, instead of buying one robot per part, I can have one robot for multiple parts. And suddenly the ROI becomes a lot better because I can run my machine for longer.
Got it. And so you're saying like the learned physics part and the learned decision making versus that classical robotic, every time restarting the problem statement from scratch is the part that differentiates your
Yeah,
system,
not,
right?
not exactly learn physics, but yeah, you get the idea. Like instead of having to rewrite like a robot program from scratch each time, our software enables you to be able to do it in a much simpler way, which basically allow like it also enables one robot to be able to handle multiple parts instead of one part. It gives you better ROI.
Is it very difficult to convince them right now, considering manufacturing is very old school thought process and people move slowly? Or maybe that's what my understanding is so far of manufacturing
Depends
industry.
on the manufacturer. There's some manufacturers who are definitely old school, but there's a lot of them who are very excited. I think a lot of our customers are very excited for our product to work and um, work in their factory for them. You know, like we've seen a lot of excitement, and I think we really want to capitalize on that at this moment, especially with like all this reindustrialization happening in the US. Nowadays, there's a new form of energy that probably most people we've not seen in the US in years around manufacturing. And I think I'm just feel blessed to be able to be part of that wave. You know, it's a lot of fun. And I think it like makes sense for like parts that are consumed in one country to be made in that country. You know, why are we wasting so much fuel shipping it across the whole world, creating these very fragile supply chains when like, hey, you should make things that you consume yourself, feed yourself. You know, it's really important to do that.
Yeah, right time and right place for you right now, considering the geopolitical situation for you to be able to do this. Okay, I want to move this a bit towards like what inspires you, your
Hmm.
journey at CMU, like people you look up to, people you've worked with. Is there? It's also for people who may be students and are exploring robotics. So I asked this question yesterday to Ayush as well. What really inspires him? So
Hmm.
same question: who or what? Both are okay.
I think one person who definitely inspires me is Elon Musk. I think like when you're building in the physical space, there's no better example of someone who's going to have a big impact as he has. Tesla, SpaceX, both are like incredible stories and incredibly hard work. Like most people tell you, hardware is like so much more difficult than doing a SaaS project, you know, or SaaS company. And Elon Musk has done that twice now. And he's making like some of the coolest things ever. Like he made like self-driving cars with Tesla electric vehicles. He made rockets that can catch themselves. And the level of organization, the level of like understanding of multidisciplinary things, not just like software, not just like understanding like one part of consumer behavior, but being able to understand like brittle supply chain, being able to understand physics, being able to understand mechanical engineering and electrical engineering and software engineering to make all these beautiful products that work really well is really something special. So I think definitely look up to him and the grit he provides. Yeah, I think he'd be the main inspiration, especially when doing something in the physical world.
Got it. And anything about CMU or your time there that kind of you recall as a pivotal moment for your decision? I know you after that were at Meta and a few other places, but is there any stepping stone or anything that happened there or mentor or any environmental cue for you to kind of take this decision?
I think definitely like the people. CMU has a lot of very smart, motivated students. So like just being around ambitious students in general, I think really pushed me to think bigger and think like different. You know, like coming into CMU, I was really scared. I was like, okay, I know there are a lot of smart people here. Will I be able to fit in? But I realized, hey, the environment is actually not that like competitive. You know, it's not like I have to like the other guys to go down for like me to succeed. It's more like we can all succeed and we're all in a really difficult place where the exams are all tough. But if we all study together, we'll all be fine. You know, so finding that kind of like community and people was really nice. And I think a lot of colleges don't provide that, so that was good. And when you say about like students, like what really matters, I think like one thing I've definitely taken away is like your peers really matter. The quality of your peers really matter. So every time you can optimize to be in a place where you're with higher quality peers, whether they're like smart, hardworking, or ambitious, or all three, the best case, anytime you have that kind of opportunity, just take it. And the more you do that, the easier the next opportunity also becomes to take, you know? So really I feel blessed that I got the opportunity to go to CMU. And then, again, like just meeting the people there motivate me to go into more and more different things, more and more ambitious things. Like starting my own company would not be feasible without doing that. One more thing I'll say is that I don't think I'd actually had the confidence to start my own company until I worked at my previous company, which was also a robotic startup. Like until I saw what a start coming out of CMU, there's a lot of different kind of people. There's some people who like where you're like, okay, I can have a very comfortable life joining big tech. Like I joined Meta, and like if I eventually joined Meta after my internship, I'd have a very comfortable life right now. The stock price has gone up quite a bit. I'd be feeling very happy. But reality is that like being that comfortable at Meta would never give me the confidence to be like, oh, I can do my own company. But when I purposely chose to be like, hey, instead of taking the safe route, join a place with more ambition, people are working harder, join an early stage startup, that really motivated me to be like, hey, I can do that myself as well. So again, that's me choosing like a place where I'm more uncomfortable. I have to work harder and I have to do more ambition. But I think it really paid off in my career to give me the opportunity to like, start my own company afterwards.
Yeah, congratulations on that, by the way.
Thank you.
You two very hard problems. Anyway, that's a wrap from my end. I have not gone too deep into technical questions just to keep the audience along. But is there anything that I have missed out? A closing thought? Anything that you would like to share before we wrap up?
No, thank you so much. It's like actually a very nice conversation, very refreshing.
Thank you for